All right, continuing on with modeling a tangent problem. So if I were to now graph this, right, I'd want to rearrange this equation to solve for, let's say, technically this, our horizontal distance would represent y, and the size of the angle would represent x on our coordinate grid. So what I want to do is I'm just going to simply cross multiply this to get 6,000 tangent of theta. So when we think about our tangent graph, right, thinking about our base tangent graph y equals tangent of x, right, the only thing that's happening here is I'm getting a vertical stretch on my original tangent graph by 6,000. So those points that were originally at, let's say, 1 and 1 are now going to be at 6,000. So if you think about our value on the unit circle, right, on the unit circle, when tangent of my 45-degree angle is equal to 1. Okay, so if I were to think about 45-degree angles, my tangent ratio is normally 1. This is going to be vertically stretched by 6,000. So at 45 degrees, this value is now going to be at 6,000. Same thing at negative 45 degrees, this value is going to be at negative 6,000. Nothing's going to change horizontally, so I'm still going to have asymptotes occur at negative 90 and a positive 90. Okay. And so sketch the graph, and we're going to talk about the restriction on the domain. So if I were to sketch this, it's going to go through here, 0, 0. So sketch of my graph is kind of exaggerated here. I'm going to take the shape of this. Okay, so that is what my tangent graph is going to look like for this situation. So if I think about the restrictions on the domain, so how am I going to restrict my domain? So technically, if we think about this plane, as this plane goes forever in this direction, this angle is getting bigger and bigger and bigger, closer and closer to a 90-degree angle. But the question is, will it ever reach 90 degrees? And the question is no, because if this ever reaches 90 degrees, then the plane will simply be parallel. The sight line is going to be parallel with the plane, which means I'm not going to be able to see the plane. We might get to an angle that is very, very close to 90 and see the plane way, way, way far in the distance, but this angle should never be 90. And then as the plane passes over us, this angle would represent 0 degrees, which is here. So if we think about that horizontal distance, the horizontal distance between me and the plane would be exactly 0. That's when it's vertically above us. And then these values, as the plane goes this way, this angle is now going to be a negative angle, because this is talking about like a different direction. I'm now looking at the plane in a different direction, which would represent a negative angle. So what would be the domain of this function? Well, the domain of this function is going to be in terms of theta, right, has to be everything greater than a negative 90-degree angle, so not equal to negative 90, but less than a positive 90, where theta would belong to our real numbers, right? Technically that angle could be anything between 0 and 90. Okay, locate the asymptotes, and then what do they represent? So we've kind of already talked about this. Our asymptotes are going to occur at plus or minus 90 degrees. Okay, and these are the points at which theoretically the line of sight becomes parallel with the horizontal distance of the plane. And then explain what happens when the angle is equal to 0 degrees. Well, at 0 degrees, the plane will be directly above the observer. Okay. The horizontal distance would be 0. Okay, and this is modeling a tangent problem.